Hello ladies and gentlemen, in this video we are going to be looking at 2023 November paper 1 question 1, which is algebra, right? So the first question, they want us to solve x squared plus x minus 2 equals to 0. So obviously they're saying solve for x. Okay, so let's get to it. So I already copied the first question here. So obviously here you have two options, right? You can either do quadratic formula or you can do factorization, right? So I'm going to use factorization because this is a rational trinomial. So I'm going to have x, and then I'm going to have minus 3 plus 4. And I always just test quickly on my brain if I'm fine. This is minus 3x. This is plus 4x. That will give me 1x there, right? When I add them together, so I know I have factorized properly. Okay, perfect. And then I now know that, okay, x minus 3 equals to 0, or x plus 4 equals to 0. You can only do this only and only if you have a 0 this side. You can split your brackets, right? You can split this bracket to be 0 and that bracket to be 0, right? But that can only be done only and only if we have what? Only and only if we have a 0 there, sharp. And then now I'm going to take the minus 3 that side. It becomes a positive 3, or x equals to minus 4. And that should give you 3 marks, right? Okay, now let's check the second one, the second question. Okay, let me do this. Okay, so the second question we are asked to solve for 3x squared minus 2x equals to 6. Then they say correct your answer to 2 decimal places. So always, if you are told to round off your answers to 2 decimal places, they are indirectly telling you that your solutions are going to be irrational. So you have to use a quadratic formula in this case. Ne? So you have 3x squared minus 2x minus 6 equals to 0. All right? And then I can see that, okay, therefore, x will be equals to, I'm writing my quadratic formula down. So it's negative b plus minus b squared inside the root minus 4ac all over 2a. Right, this formula is given on the formula sheet on your final exam, but I advise you to know it off by heart, right? Then ladies and gents, we can see that our a will be 3, our b will be negative 2, our c will be minus 6. So now let's see. We're going to say, okay, therefore, x is equals to negative, where there's b, I put a negative 2, because b is negative 2, minus 2, plus minus square root of, okay, let's move this a little bit. Our b is minus 2 squared minus 4. I'm sure you see that I always use brackets when I substitute. 4a, and then my c is minus 6 all over 2 and then a, right, which is 3. Then now let's see, what does this give us? X equals to, or remember you're gonna get 2 answers, right? X equals to. So let's see. I'm going to put this on my calculator quickly. Okay, so I'm sure you're also doing that. Okay, let's see. So we have negative b. Okay, so yeah guys, also just be putting on your calculators. Let's see. So there, and then we put our values. So my a is 3, b is minus 2, my c is 6. Okay, so guys, the first answer I get 1 plus square root 19 over 3. Then obviously the other one will just be the same thing but with a minus here, right? 19 over 3. And then you obviously have to, let me just bring this down because we're going to use it. Okay, here we're going to have x equals to, let's see now. So when I SD this, I get negative 1.12. Ne? And then the other one, let's see. The other one, when we SD, we get 1.79. And those are your two answers for this one. Okay. So we can move on, ladies and gentlemen. Let's move on. The third one, we basically have square root of 2x plus 1 equals to x minus 1. Right. So ladies and gents, when you have an equation with a square root or a cube root or whatever root, ne? But in your level, you're always going to be given the one with a square root. Ne? So a square root, you make sure that it's by itself. So every other thing must be on the right hand side. Now the square root must be alone on the left hand side. Sharp. So the square root is already isolated in this case, so we can work with it. So we know that to remove a root, we have to put the exponent. So we square. Right. Remember, here there's an invisible 2 basically for the square root, but we never show it. Right. Awesome. So when I square this, I'm left with, this side I'm left with 2x plus 1 because the square cancels the square root. But this side I also need to square. So this side I have two brackets like this, x minus 1. And then another x minus 1. Right. And then we can see that, okay, now we need to factorize. We need to multiply here. So I'm going to have, okay, this side, let me just leave it like that for now. Here we're going to FOIL. So x times x gives us x squared. This we get minus x. And then we do the same here. We get minus x. We do the same there. We get plus 1, right? So I'm going to say 0 equals to x squared. This and that. This one and that one give us minus 2x because they are like terms. Right? And then I have plus 1. And then because I put 0 there, it means I need to move this one and that one to the other side, right? So I'm going to have minus 2x minus 1. The signs must change because we are moving to the other side. And then let's see now. We have 0, right, equals to x squared minus, let's see, minus 2x and minus 2x will give me how much? It will give me minus 4x, right? So minus 4x. And then if you check, plus 1 and minus 1 cancels out. So this is what we are left with basically. And then from here, we can see that, okay, we need to factorize now, right? So we're going to take out a common factor because this is not a trinomial, right? But if you want to, you can use a quadratic formula, ladies and gents. Your a will be 1. Your b will be minus 4. Your c will be 0 because we don't have a constant, right? So you can input those values on your quadratic. You're still going to get the same answer. So you have 0 equals to our common factor of x. And then we're left with x minus 4. Right, and I quickly check if I were to FOIL here and here, this will give me that, right? X times x will give me that, and then this, and this and that will give me this, exactly. This and that will give me that. Then I know that this is amazing, so we can move on, right? Awesome. So that's 4. Now remember, if we have 0 here, it's easy to use the zero product principle. So this we can treat it as a bracket. So we can say this bracket equals to 0 and that bracket equals to 0. Or, right? Sharp. So we're going to say, okay, 0 equals to x or 0 equals to x minus 4. And then I need to move the minus 4 to the other side. So it gives me 4 equals to x, right? And you might think you are done, ladies and gents, but when you deal with sets equations or equations with irrational roots, you always have to test your answers. So I'm going to quickly do a test to see if my solutions are fine. Always when you do a root equation, test. So my answer is what? It's 4 and 0. Okay. So let's write what we had originally. This is what we had originally. We had 2x plus 1 equals to x minus 1. Now let's check when we put 0. If I were to put 0 here and there, this side I'm left with minus 1, because this guy here will just be 0. And then this whole thing here will be 0 if I were to put 0. So I'll be left with square root of 1, which is 1. But that will not be equals to that. You see it? So 1 is not equals to that. So which means x equals to 0 is not true. Right? So you go back here. You're like, okay, this guy is not true. Now let's test 4. You always have to test for root equations. So let's test 4 and see. So for 4, I'm sure you can see that here we get 4 minus 1, which is 3, right? This side we're going to get 2 times 4, which is 8, plus 1, which is 9, and then square root of 9 is 3. So 4 is going to be true because it gives us that. So you always have to test on the side. There's otherwise you are going to lose 1 point here, ladies and gentlemen, for not testing, right? Awesome. So we can move on now. Let us move on. Okay, awesome. So now the next question is an inequality. Okay, so we have x squared minus 3 is greater than 2x. Right, that is an inequality for 4 marks. Okay, let's see how we were supposed to do this one. So this one, ladies and gentlemen, we can see that, okay, we have x squared minus, I'm moving sorry about that, I'm moving the 2x to the other side, so it becomes 2x minus 2x, and then it's gonna be minus 3, which was already there, right? Which is now greater than 0. Now here you have a rational trinomial, so I can basically factorize it, right? So let's get the factors. The factors is x, the x squared breaks into x and x, the 3 will break into 3 and 1, but we need -2, so I'm gonna put the negative on the 3 and there. And I always check, guys, no matter, I know I'm advanced, but I still check to make sure. So this and that gives us minus 3x. This and that gives us plus 1x. Minus 3 plus 1 will give us minus 2. Then we know we're factorized properly. Always check when you factorize. Just double check all the time. Right? And then now we can do this. CVs for critical values. You can see that it's going to be x plus 1 equals to 0, or x minus 3 equals to 0. Then x equals to 3. That is the first answer, because I just moved the minus 3 to the other side. I also need to move the positive 1 to the other side. That will give me x equals to minus 1, right? Those are my critical values. Okay, sharp. Now that I have my critical values, I can do this. I can draw a small parabola here, right? My parabola is facing up. Why is it facing up? Because if you check here, this sign here is positive. This sign here is positive. So this whole part, this is a parabola, guys, right? This parabola is facing up because your A is positive. Okay? Sharp. And then its x-intercepts are your critical values, basically. So this side you have -1, that side you have 3. All right, now let's check. They say we're looking for where the graph is greater than 0. The graph must be what? Positive. Greater than 0 means positive. So we're looking for where the graph is above. Remember, the graph is positive here, 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 here. Here the graph is negative, it's below the line. Do you see it? So this part, the graph is negative. This part, the graph is positive. So we're looking for the positive part. All right. So I'm looking for this part and that part. But this part, I'm actually, as the graph goes up, I'm actually going there. Do you see it? As the graph goes up, I'm actually going there. All right. So now my answers are going to be, okay, x. As I go to the left, as I go this way, am I getting bigger or smaller? I'm getting smaller, right? I'm reducing because I'm going to the left. So x will be less than -1. Then you always have to use or. Don't say and. You must say or. X, as I'm going to the right, the x value is getting bigger. So you're going to say x values are getting, they're getting bigger than 3 as we go to the right. And that is it with your inequalities, ladies and gentlemen. Let's move on to this. All right. Let's move on. Okay. Let's see here. Okay, now they want us to solve for x simultaneously. We can do that with ease. So let me just copy the questions. So we have x plus 2y. X plus 2 equals to 2y. And we also have 1 over x plus 1 over y equals to 1, right? Those are the two equations we are working with. All right. So let's see, ladies and gents. If you check here, you have two equations. This is your first equation. That is your second equation. All right. Perfect. So you always have to pick the easy equation. And that will be a linear equation. So in your level, they'll always give you a linear equation and a certain type of a curve. Be it a parabola, be it a circle, be it an ellipse, and so on, right? Perfect. So now, but you always start with your simple one, which is this one. Okay, I'll call it equation 1. This one I'll call it equation 2. Equation 2. All right. So now, let's see. You have x plus 2. Okay, let's do this actually. We are going to make x the subject of the formula here because x is already isolated. I'm not choosing y because if I choose y, I'll end up working with fractions because y has a coefficient of 2 and x has a coefficient of 1. So I always choose the one with a coefficient of 1. Okay, so now we're going to have 2y, and then I take the plus 2 to the other side. So I'm going to have 2y minus 2. Do you see it? Minus 2. And this is still equation 1. It didn't change. I just rearranged it, right? I just moved this to the other side. Alrighty. Perfect. Now, we're going to always substitute. So we sub 1 into 2. Into 2. Right. Okay, let's see. Into 2. Sharp. Okay, now let's see. Where I see x, I'm going to put this guy, right? Sharp. Let's see. Okay, let's see. So I have, okay, I'm going to firstly write this in this form. If you check there, we have an LCD of xy, guys, right? We have an LCD of xy. So equation 2, I'm just going to add with red. Here we need to have y, here we need to have x, here we need to have both xy so that the bottoms are all xy. So whatever I added in red, I have to multiply with it on top, right? Here I have to multiply with x, here multiply with xy. Sharp. So equation 2 is basically can be written in this form. Y plus x equals to xy. Remember, now that the LCD is the same, it's common, I mean all the denominators are the same, we can just drop them, right? Sharp. And then now we can easily substitute x. Let's now substitute x. So whenever I see x, is like I'm seeing 2y minus 2, because I'm saying x equals to 2y minus 2. So we are going to do this. We are going to have y equals to, y plus, where there's x, you see here, I have x, so I'm going to replace with that. So it's 2y minus 2, which is equals to, I see x here, so I have to replace with that. So I'll say, okay, in brackets, 2y minus 2 multiplied by y. All right? And then I have y plus 2y minus 2 is equals to, let's check here. I'm going to FOIL there, so I'm going to have 2y squared minus 2y, right? Okay, I'm going to make it thicker now, sharp. So now let's move on. I'm going to now move everything to one side, so I'll leave 0 here, is equals to 2y squared minus 2y. So this must move, so it's going to be minus y. This must move, minus 2y. This must move, plus 2. Then 0 is equals to, let's check now. We're going to have a, let's see. 2y squared doesn't have a mate. Minus 2y and minus 2y, and minus y gives me minus 5y. So we have minus 5y, right? Plus 2. My 2 looks like a z, ne? Let me just write it nicely actually. So plus 2, right? Sharp. And then now we have a nice trinomial, of which you can either decide to use your quadratic formula, or we can decide to factorize it, ne? But I always prefer to factorize, because that tests my skill of factorizing, which is very important. We don't have to always depend on the quadratic formula. All right. So now, but that is your backup in case you can't factorize this trinomial. Just know that always when you have something to the power of 2, you can just always use your quadratic formula. So in this case, we can see that we're going to have 2y and we're going to have y, right? And then I'm going to put 2 here and then 1 there. And then all will be minus, right? Obviously, if you put it not correct, okay, let me show you something. Let's say I did this, ne? Let's say I put 2 here. I'm going to do it incorrectly first and show you, sharp. So let's do that. So if we multiply this one and that one, you get minus 2y. This one and that one also give you minus 2y. So minus 2y and minus 2y gives you minus 4y, which is not minus 5y. So you know you haven't factorized properly. You need to fix. So I'm going to remove that and switch them around and try again. Oh, sorry. 1 and then 2. Now let's see. We're going to have minus y minus 4y, which gives us minus 5y. Minus y minus 4y give us minus 5y. So we are fine. All right. Now that we know that we can use the zero product principle, you're going to say 0 equals to 2y minus 1, or 0 equals to y minus 2. Then here you can see it's easy. We can move the minus 2 to the other side. So it becomes positive 2 equals to y. Then this side, we're going to move the minus 1 that side. So we have positive 1 equals to 2y. Then divide everything by 2. Therefore, you can see that y equals to half, or y equals to 2. All right? Now we need to find the x values, right? If I remember well, the x value was x equals to 2y minus 2. Okay. So we have x is equals to 2y minus 2. All right. So I'm firstly going to say, therefore, x equals to 2, I put half minus 2, or x equals to 2, what is our other x value again? Is 2, ne? I mean our other y value is 2. So I'm going to put 2 here. Oh, sorry. We're going to put 2 here, and then we minus 2. And then here we have this, this gives us minus 1, or 4 minus 2, x equals to 2. Those are the two x values, ladies and gentlemen. And we are done with solving the simultaneous equation because we have the two x values corresponding to the two y values. Some people prefer to write their answers this way, ne? So the x value here is -1. So -1 coordinate the y value, which is half, or the x value on the second one is 2, of which the y value is 2. So those are your point of intersections. Remember, simultaneous equation, you are just getting the 2 points, ne, where the graphs are going to touch each other. All right, so this rule is going to help you also in functions. If you are looking for point of intersection, or the point where the two graphs meet, make sure you do simultaneous equations. Sharp. So now let's see. We can go to the last question. Where's our question paper? Okay. So I'm going to move this down. I need to do this first. Okay, let's move it there. Let's pick this and do this. Okay. Sharp. Now let's see. Last question. Eh? So on the last question, let me just copy quickly what we are given. So we are given 2 to the power m plus 1 plus 2 to the power m equals to 3 to the power n plus 2 minus 3 to the power n. And we are told that m and n are integers. Ne? Where m and n are integers, determine the values of m plus n. So we need to find the actual value of m and the actual value of n and add them together to see what the value will be. That is what the question is asking here. We need to add m plus n. Okay, so let's do that, ladies and gentlemen. Let's do that. So here, ladies and gents, this looks interesting, but it's very, very simple, right? When I see exponential expressions, there are two things that comes to my mind. Ne? The first thing is, are all the bases prime numbers? So I'm going to check. I always make sure that all the bases are prime. So in this case, all our bases are prime numbers. So we cannot prime base them because they are already given in the prime base form, right? Sharp. So I'm going to now do this. 2 to the power m, I'm splitting there, dot 2 to the power 1 plus 2 to the power m is the same as 3 to the power n dot 3 to the power 2 minus 3 to the power of n. All right, perfect. And then now let's check. If we were to check this now, there is something common here. So here you have this being common to that. And we have two terms. This is the first term, that is the second term. So we can take it, the common part, as a common fact. So 2 to the power m goes out. And then the plus sign is still there. This side we are remaining with only this, right? Because that one went out. So you're left with 2 to the power 1, which is just 2. And then here you're left with 1, right? On this part here, we are left with 1 because it went out. Sharp. And then we're going to do the same this side. We can see that 3 to the power n is a common factor. We're left with 3 to the 2 minus 1. Right. Now let's move on. You're going to have 2 to the power m dot 3, because 2 plus 1 is 3. I'll say 3 to the power 1 is equals to 3 to the power n dot And 3 squared minus 1 is 8, right? Because it's 9 minus 1. So you have 2 to the power m dot 3 to the power 1 equals to 3 to the power n dot 2 to the power 3. Remember, if you're not sure how to convert, you have to say, okay, make sure that your calculator is on, and then you press 8 equals to, you go to shift, and then you press fact, which is where you have like 3 semicolons. Then that answer gives you 2 to the power 3. And now we are done, ladies and gentlemen. Because check, this one here goes with that one. So you can see that your n is basically 1. Therefore, n equals to 1. And let's check m. You can see that, okay, this one goes with that one. It means the m must be equals to 3. So you're going to say, okay, m is equals to 3. And then they wanted us to get n plus m, right? N plus m or m plus n, which is the same. N is 1, m is 3. So the sum of m and n will be 4. And that's it with question 1, ladies and gentlemen. If you found this interesting, you can look for question 2 and 3 and 4 and 5 and 6. Thank you very much for your time. More videos like this will keep on loading. Aluta continua.